Hi everyone, welcome SAS Programming 90 days. Today is day 38. Welcome to SAS VIYA session. In the last session, we are doing econometrics in the SAS task. Okay, so we are going more deep in the econometrics. First, we will start with the linear regression. So what is a linear regression? Linear regression is a linear model, a model that assumes the relationship between the input variable x or a single output variable y. Okay, the linear regression is showing the relationship between the two variables. Let's suppose we have the x and the y variable. Okay, so we have one dependent variable will be there. So according to dependent variable and the independent variable, two variable we have, let's suppose x and the y, and with the linear regression we will see the relationship between the both variables. Linear regression is a process of finding the line that best fits the data points available on the plots so that we can use it to predict output values from input that are not present in the data set we have, with the belief that those output will fall on a line. Okay, so let's see we will see the example in the SAS VIYA. In the econometrics, how we are creating the linear model. So in the linear model that we are using in the cross-sectional data model task. So this is the task that is available in the econometrics. So linear model, to perform the analysis of a linear model, you must and input a data source, you must assign a variable dependent variable role. Okay, so here we have the linear regression. We have three variables that we need to declare. Okay, so mandatory is only the dependent variable. Linear regression task feeds a linear model to predict the single continuous dependent variable from one or more continuous or categorical predictor variables. This task procedures statistics and graphs for interpreting the results. So what is a dependent variable? Dependent variables specify a numeric variable for the analysis. Continuous variable is a specific independent covariates regressor for the regression model. If you do not specify the continuous variable, the task fits a model that contain only the introspect. Okay. So, and what is a categorical variable? Category specify the classification variable. The task generates a dummy variables for each level of categorical variable. So let's see how we are declaring these all the variables. So this is my SAS studio. In the SAS studio, we selected the developer SAS code. We are in the develop and the SAS code. Here we are. So we are in the econometrics. We are doing the cross-sectional data model. So I click on the cross-sectional data model task. Okay, so that window will be open, and first of all let's suppose I selected one data here, that is data is related to the SASHELP.CLASS. Okay, now they are saying the dependent variable, give me dependent variable. Now you can see here in the task console the mandatory variable, they are showing what we need to declare first for creating this dependent this regression, linear regression. We need to select dependent variable first. So I click on the dependent variable and I selected the dependent variable as a weight. Then okay, and in the classification in the continuous variable I will be select the age and the height. Okay, and now the mandatory field is select a model type, so that is available in the model tab. Then I'm selecting the model as a linear. We are creating the linear regression. Okay, now you can see here automatically they created one code here according to our selection. Okay, so code is here. So they are using the proc autoreg, with the class, and this is the model. My model is the dependent variable is weight and independent variable is the age and the height. Okay, so and this is the done. Okay, let's first run this, then we will go more deep in the linear model, how we will what we are seeing in this model. Okay, so now I run, now you can see here dependent variable as a weight here, and now you can see here we have the SSC, MSC, all the uh, mandatory analysis are here. Introspect, this is the age, this is the height, okay, so estimate standard error, we have t value, approx value. Okay, now we have the fit diagnostic for weight. So this is the standardized results. We have observations. Okay, so here we have the present one, and this is total how many observations we have, 19 observation. MSC we have 132.50 5062, and the model DF is 3. So this is the linear model, so what we created on our data. And also here we have the category variable. Let's suppose if you want some category variable or the group variables, you can add. Let's suppose I'm group adding the group variable with the gender. Okay, so now we need to run it again, our code, because I added one group analysis there. Okay, now you can see here we created for the gender group wise. First is related to the female F we have, then we have related to the male. If you want as a group by different you have some categories, so you can do it with this feature group by analysis, and you can customize, you can distribute our model with the different one. Okay, so now you can see here easily. Now if your weight is increasing, okay, weight is increasing when your this numbers also increasing. Okay, so we have around 100 weight here, and the maximum is going to 8. 9 observation in the female, and the in the male we have the 10 observations. So this is the one model, and also we have here. So now let's suppose I'm looking for the correlations of the parameter estimates and the covariance of the parameter estimates. So we can select, we need to select the hit this analysis heterogeneous, and we need to give here the variable, here also variable on the variance function. So let's suppose I'm selecting with the age. Now you can see here I selected the age. Now this they will be showing the correlation of the parameter estimate and the covariance of the parameter estimates. So iteration history of object function, and the parameter estimate, this is the option analyze heterodicity option that is available in the model tab. So we need to select this and we need to create it. So in the plots, so they giving the diagnostic plots and such as a residuals, normal quantile plot of the residuals that is presenting here. And in the options we have the statics option. Let's suppose if you want to default statics, if you want to default and the additional statics, so you can. And also we have the default plots we selected. If you want some specific so you can create it. Let's suppose if you're looking for the individual plot, so now they will be create the individual plots for everyone, so that you can do it. So in this data, because we don't have the individuals category here, so that is not that's the reason it's giving the error here. So if we have that data that we can customize with the individual, so we can. And also we have the statics, different types. Also we have the metrics. If you want the other outer product matrix or the inverse Hussein matrix. Okay, so you can select it and you can create it. Let's suppose I created the inverse Hussein matrix. Haseen, now this is the inverse Hussein matrix is here. Okay, and here we have the output data. Now if you want save this output data, so you can save it in your data. Let's suppose I want the predicted values only, so I selected the predicted values and they will be save the predicted values in my data only. Okay, and this is the information of my model. So what we created the name as a cross-sectional data models, and description is analyze the cross-sectional data. Folder is Econometrics, and the procedure is auto reg and QLM, and the count reg here. So this is how we are creating the linear regression model with the dependent variable, independent variable, how we are selecting and how we are using the cross-sectional data model. In the cross-sectional data model, we have many model there. So today we are done the linear model. Okay, now we will go more in the more models in the coming sessions. So this is the code what we generated here. So first of all, we done the proc sort, then we done the auto reg for the homogeneous relationship that we created the age with the link express, and then we done by the gender. So gender is here, and the output will be there. So output out will be the work. In the work, we are saving this data. Okay, so now if you want to check this into the work, now you can check here. So this is my data that only the predicted values will be here for this model. Okay, so now you can see here this is the predicted one. So then all my data name, genders, age, height and the weight, only the predicted values are here. So this is how we are creating the linear model in the cross section in this SAS VIYA task with the econometrics. Thank you guys.